Welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Breuer. Please have a seat, join us for one of the last two presentations of the day. I would like to also welcome our guests watching the live stream online today. There are also some coffee, some drinks for free. Just have a seat and enjoy the upcoming presentation regarding hydrogen storage tanks, testing, certification, codes and standards. With me on stage today, hydrogen project manager of Hexagon Composites, Patrick Breuer.
Hello.
And Engineer Director Program Management of Experian Energy and Environment GmbH, Dr. Thorsten Weber.
Hello. So, thank you very much for the invitation and the introduction. So, initially, I would like to give you a short overview of the Hexagon Group. The Hexagon Group is divided in two different business areas. On the one hand, we have the low pressure area for LPG applications, and on the other hand, we have the high pressure area for cylinders for storage of CNG and hydrogen. So today we want to focus upon the high pressure area and thereby especially on the hydrogen products. The previous year was characterized by significant variations in the Hexagon Group. So the key strategic developments in 2016 were the cooperation agreement with Mitsui, the merger with Agility to create Agility Fuel Solution as a 50-50 joint venture between Agility and Hexagon. And last but not least, Hexagon acquires Experian Energy and Environment and strengthens its position in the composite pressure cylinder market. As a result of these strategic developments, the global footprint of the Hexagon Group has been expanded significantly. As you can see on the world map, the blue sides representing Agility Fuel Solution and the orange and black one representing production sites and sales offices from Hexagon as well as former Experian sites. Here I want to highlight the production site in Kassel. We have here increased our production capacity in the middle of Europe in order to serve the German and European market. After that brief presentation of the Hexagon Group, I would like to summarize the main requirements for hydrogen storage cylinders. So we have as a requirement low weight, compact construction and high fatigue resistance. Based on these requirements, we will focus on high-pressure storage systems. Well-established storage systems could be differentiated into 4 different classes. First, we have the Type 1, which consists of a full metal construction representing 100% of weight for the comparison with the 3 other types. The second type is a Type 2, which is again a metal construction but now reinforced in the cylindrical parts with a carbon fiber laminate. Type 3 is coming with a steel or aluminium liner and a totally overwrapped composite laminate, as you can see here. And then last but not least, Type 4 with a polymer liner and a complete overwrapped composite laminate. Based on the advantages, as you can see, of the low weight and the high fatigue resistance of the Type 4 technology, Hexagon is focused on the Type 4 technology solution. A Type 4 cylinder consists of a thermoplastic liner, a CFRP laminate, optional with drop protection or impact protection layer, and a valve interface. In addition to the already listed advantages of the low weight and the high fatigue resistance, the thermoplastic liner and the laminate are not subjected to corrosion and hydrogen embrittlement. Hexagon hydrogen cylinders are available in pressure ratings from 250 bars up to 950 bars. But now, before focusing on testing and certification, I want to give you a short overview of the wide range of applications. Hexagon is very well positioned across the hydrogen value chain. The applications could be divided in 3 different categories. First, the distribution of gas from the production sites to the customer, for example, with such trucks. A typical project in that business area is a 500 bar storage system for our customer Linde. For example, this trailer has a storage capacity of hydrogen from 1,100 kilograms. The second category is stationary applications, for example, for refueling stations, backup power system, or ground storage systems. And the third category is representing mobile applications for powering cars, buses, trucks, ships, and trains. As example for actual mobile projects we are involved in, I want to highlight the Alstom project for railway applications and the Daimler GLC project for automotive applications. So thank you very much, and I will hand over to my colleague Patrick Breuer for the next part of the presentation.
Thank you, Thorsten, for the first slides. Okay, I will stay here. As a second part of the presentation, I will talk about testing, certification, codes and standards for the high-pressure tanks we are producing. First of all, I would like to give some definitions. What are regulation, codes and standards? So on the highest level, we have the regulation, which is a legally binding document, which is normally established through international agreements. Many times these regulations on the other side refer to codes and standards as a baseline. So there's an overall correlation between regulation, codes and standards. And one good thing in the regulation is that many times they are developed in advance of the broad commercialization of the products to have established already a baseline safety. If you talk about codes, they specify requirements. They are published by voluntary groups and usually established and adopted by jurisdictions. And they are also legally binding. So they are, let's say, the second level of the certification requirements we have to consider. And then finally, the standards that provide the technical guidelines for design, manufacturing, and testing. They set minimum requirements to have a safe product out in the field. They are normally established through technical experts who are meeting from time to time to review the standards and see whether they are up to date or whether they need to update it based on lessons learned from the field experience. But they are typically voluntary. They only get, let's say, mandatory if they are adopted in regulation or codes. If we look which organizations are, let's say, establishing the different type of certification topics, we start at a very high level of the United Nations, where we have on one side the regulatory authorities who provide the regulations for example, transport on the road for the United Nations. And then we can have different applications, like whether we have a transport of dangerous goods, which is a transport application, or we have UNECE regulations, Work Package 29, who is dealing with vehicle regulations on a broader base, and they provide then finally regulations like the GTR or the R134 that are the guidance for the certification for the vehicle applications, and the ADR as a regulation for the transport application. In parallel, we have the standardization organizations also on an international level, which is mainly the ISO, IEC, who are dealing especially also with hydrogen technologies, road vehicles, or gas cylinders. On the next level, we have the level of the European Commission and the Fuel Cell Joint Hydrogen and Joint Undertaking, which provide, based on the regulatory documents, additional legally binding documents, like, for example, directives, which are for the hydrogen storage tank very important, for the stationary applications, the PED, and for the transport expectations, the TPD, or for the vehicle applications, on the other side, vehicle-specific regulations. For the standardization organization in Europe, it's mainly CEN, CENELEC, and of course others not to mention here. And the last station would be then the member stage, who can also, each of the member states can basically issue special or additional codes based on the above mentioned UN or ECE regulations. And on the other side, also on the national level, the standardization organizations can issue standards that need to be considered. So if we look at a world map, we have a lot of different organizations, a lot of different documents, certification baselines that need to be considered. It's very complicated to have, let's say, one certification, a type of certification which is valid for the whole world. You always have to look in the different countries, at least at this point in time, to find out which code, which regulation is need to be used to get a certification. If you look at the different application, we are basically serving with our storage tanks. The light-duty vehicles are one market segment, and here's just the list of possible regulation codes and standards that need to be considered. It's a long list. It's depending on the country, the area you would like to get approval, you have to fill one or the other standard. For the heavy-duty vehicles, which are mainly bus applications, the list is a little bit shorter. For the transportable applications, we have another set of documents and regulations, like TPAD and ADR as mentioned, or DOT. So it's not yet established that we have one regulation or one standard for the different type of applications that serves basically harmonization all over the world. And as an example, the LDV, the fuel cell battery vehicle certification, we started, let's say, beginning of 2010 with different codes and standards for US, Europe, and Japan. So it was very complicated to get one tank certified for all the different countries. And then it was the Global Technical Relation established in 2013, which was seen as a base where all the participants can see this. This is the base we're going forward. And then the first in the US and Canada, the HGV2 was established, which was a carryover of the GTR requirements. And then also Europe, and finally also Japan adopted these requirements in the UNECR 134. So we have now one base requirement that we can serve for at least Europe and Japan. It would be very great if this is all, but also in Japan, they think, okay, we need some additional requirements to the UNECR 134, so we create another set of requirements in addition. So also here we need some additional test programs to be done to get final approval in Japan. In the US and Canada, the main code for the vehicle application would be the FMVSS. And there's now discussions ongoing or evaluations ongoing to adapt also the GTR within the new update of the FMVSS, which would be, of course, very good to have also the same base for the certification in the US, in Europe, and in Japan, which are the main markets for the fuel cell battery electric vehicle. Another important topic is always the ISO. ISO documents are very well established in all over the world, and there's a document in progress which basically combines the GTR requirements with some other local requirements, and that could be seen as a very accepted standard for applications all over the world. If you talk about specific tests we have to do, or we are doing, to guarantee that the product is safe for the purpose, we have as one part do strength and life cycle test to prove that the high pressure cylinder has a minimum safety. In addition, we do damage tolerance tests, where we show that even if we have a slight damage on the cylinder, it will not be a catastrophic event immediately. And we have environmental testing, where we say, okay, we prove that the cylinder is also usable in the environment of the vehicle. One important part is also the bonfire test, to show that if we have a fire on the fuel cell vehicle, we have a safe relief of the pressure before we have any safety issue. Just one comment to this, let's say, procedures, they are all basically done on one test, one tank, with 1 or 2 stress factors per test. And in the new regulations, this approach has changed a little bit. We have a sequence of these stress factors which will be applied to one tank, and this tank has to survive the whole sequence till the end. This is, let's say, a different way to test. But it has shown some improvement with regard to the products. Similar is true for the gas cycle test. In the former times, it was basically one temperature level, just cycling with gas. Now we have different temperature levels, which is a more severe test, and of course improves the performance and the safety of the products. Another part is the fire testing we have talked about right now, just before. Also here we have some new approaches that will improve the safety finally. But again, this is a new approach in testing. It's multiple stress factors per test, which have advantages and disadvantages. In addition to the testing and the general applications of the codes and standards, we try to be involved in the establishment and updates of codes and standards. So Hexagon is participating in all relevant working groups to form the standards, to be sure that the standards are representing what is needed, and also develop new requirements if necessary. Another part of our activities are research and development activities, because there is still need for new lessons learned, new experiences with the product. So we have different kind of European projects we are participating, also funded by the Norwegian Council as well as the DOE, where we learn together with our customers more about the products and the needs. As one example is in this case the Hypactor project, where we try out the impact behavior of the cylinder. You see the cylinder is impacted by a bullet-shaped impactor, and of course the goal is at the end to find out what are the critical impacts that would lead to a burst or a failure of the cylinder, and what are the limits we can apply to our products. And to have that lessons learned, also give input into the customer usage profiles to be sure that these products are safe integrated in the vehicles. So finally, we think that on an international basis, we still need pre-normative research, because we still have a lot of areas we need to know more. But also on an international level, we need harmonization of the codes and standards to be able to have a final deployment of the hydrogen products in the public. Thank you very much for your attention.
Thank you very much, the two of you. Are there any questions from the audience?
You mentioned in your lecture only testing of new equipment. What is about the life cycle of this equipment? How it should be tested, or are there regulations for the periodical testing?
This is of course another part that needs to be, let's say, studied. We have standard inspection procedures which have to be done on a regular basis, but that's something that needs to be developed over time to improve that and to have a better understanding of the behavior of the products in the field over the time.
Further questions? You've mentioned you are part of developing those new standards and regulations.
Correct.
What do you wish for the future? That other companies are more involved as well, or you rather do consulting for other companies that are not on the same level, or what do you expect or wish for the future, despite having a common sense?
I think it would be very beneficial if more from the technical side and more provider of the technology is involved. We have, of course, very much involvement from bigger companies, but I think there could be a much broader base, because finally it's in our interest that the regulation codes and standard provide the baseline for future developments, so that we have safe products out in the field. And I think we all would be interested in improving these codes and standards, and more people with more knowledge can definitely be a benefit.
Yep.
Definitely. Thank you very much for your time and your presentation.
Thank you very much.
One more warm applause for the two of them.
Thank you.
Thank you.
If you missed the presentation or you want to watch it again, everything will be online about tonight or latest tomorrow morning on our website, so you can watch it again. Now I would like to continue with our last presentation in about 2 minutes regarding a practical example, hydrogen, a connective link between heating, electricity and transport sector by HTEC Systems. Please stay with us for the last presentation of the day. Have a coffee, have some refreshments, and see you in a minute. Thank you very much.